Okay, now members, let us see how we handle this question. Two airfields A and B are 500 kilometers apart, with B on a bearing of 60 from A. You hear that word from A. An aircraft which can travel at 20 kilometers, 200 kilometers per hour in still air is to be flown from A to B. If the wind of 40 kilometers is measured blowing from the west, find the true speed of the aircraft. Remember, in still air when there is not any wind, but when the wind is blowing, there is some velocity that is going to act on that plane or aircraft as it's going. That's what we call the true velocity. The true velocity in simple terms is the resultant. When you combine the velocity of the plane and then the velocity of the wind, that's what we call the true velocity and what we call the resultant. So you can consider it in this way of the vector approach or the geometry approach. So the vector approach, we first come at A. This is our A at 60 degrees. So remember the bearing involves A. Remember that it from A. So if we get this bearing, we are going from B. We are going to B. So this is our A. So if we have this, we can resolve this vertically and then also horizontally. So vertically, this is adjacent, so it's going to be 200 cos 60. And then this is going to be the opposite, which will be 200 sine 60 degrees. So meaning the velocity of the aircraft is going to be the x coordinates, the horizontal component, which is 200 sine 60 degrees. And then the vertical component, you see that it's going in the positive, even this one is the positive. 200 cos 60 degrees. Okay, then we come for the rest of the wind. Now, the wind, if the wind of 40 kilometers per hour is measured blowing from the west, that's why you see that we are from the west. We are going to say that from the west. So there, the velocity of the wind is going to be the x component, you see it's in positive direction, so it's going to be 40. Then the y component is 0, because this is purely horizontal. So now our resultant velocity, Vr, is going to be the velocity of the aircraft plus velocity of the wind. For our aircraft, it's going to be 200 root 3 over 2. Then this would be 200 into a half, cos of this and cos of that. Then plus 40, then 0. So that will be, so now our resultant is going to be, this is going to be 40, okay, or it's going to be 100 root 3 plus 40, then this will be 100, as simple as that. Note that cos 60 is a half, and then sine 60 is root 3 over 2. So from there, I think we can see that we can get our resultant. Our Vr is going to be the square root of 10 root 3 plus 40 squared, then plus 100 squared. We cannot add this and this because this is the number and this is the side. So, but you can leave it for the small pieces if you want. Okay. So here I'm getting 235.491 8 kilometers per hour. So this is the true velocity of the aircraft. Then the direction to be set, they are telling us the direction to be set, so we get from here, I think we can see all of them are positive. So what we have in the part B, this was our part A. Then part B, so this is what we have said. We have this as 100 and this as 100 root 3 plus 40. So the course we have set for this resultant is going to be here. We set the course from the north line. So you see we can easily get this. So from there it's that our tan alpha is going to be the opposite. The opposite is this, which is 100 root 3 plus 40, the whole over 100. And so from there, my alpha will be so 64.87 degrees. So meaning the course we should set is north 64.87 degrees towards the east. As simple as that. So there we have finished the question. Then you either use this method or this. The geometry approach, here the geometry approach, what we do, we have first of all, let us start. They are on the bearing, so we start with A. So if this is going to be my A from here, okay. If I start with this as my A, so they're telling me that B is on the bearing of 60 from A. So if this is 60, then when I go to that bearing, I'll come to B. A. Sorry, we have missed time. We have missed time here. Oh, sorry. Anyway, I'm going to handle it together at once because you have the resultant, you have the distance, so you can easily get the time. But let me handle it here. Okay. So from there, you see this one, the velocity which the aircraft is using is going to be 200 kilometers per hour. So this is our B. Remember, wind is blowing. You can put the wind there or you can put it here. No problem because it's going to be blowing either here or here. But now let me choose to put it here. So that I have the resultant. I can get my resultant in ease. So that's going to be now my wind at 40 kilometers per hour. This is the velocity of the wind. This is the velocity of the aircraft. So now my resultant is going this side, then this side. So my resultant would be this one here. That's going to be my resultant, which I'm going to call V R. So it's that this one here is going to be 9. So meaning the whole of this angle here is 150 degrees. I think you see that from there. We can use the cosine rule. So our cosine rule, from there, you can see from cosine rule, we have this, we can make that. So VR squared will be equal to 2, 4 squared plus 200 squared minus 2 into 200, 40, then cos of the angle, which is 150 degrees. So from there, our VR is going to be my VR 40 squared minus 2. So it's going to be 235.491 kilometers per hour. Then the course we should set, of course, now not here. The course we should set is the course, this is going to be our alpha there. So we need that angle. But anyway, what do we have? If we have this angle, this one, let us call this one as, so we have this, we have the angle, we need this angle. So if I call this one 90 minus alpha, but that one no. Okay. I can call this because the whole of this 90, so I can call this 90 alpha. I have this. So then we call this 90 minus alpha. So that I can use sine rule, my sine rule. Sorry, a little bit, someone is calling me. Okay, so using the sine rule, we have, this is the opposite angle. So you have this, we are going to be having now 200 over sine of 9 minus alpha equal to this VR, which is 235.4918, the whole over the angle opposite, sine of the angle opposite. And so from there, you can see that my 90 minus alpha is going to be, when you compute, then after you get the sine inverse, what angle do we have? So this one I'm having 25.13 degrees. And from there, then you can see that our alpha there is going to be 64.87 degrees. I think you can see it's the same angle we had there. So therefore, we can get our time, that is the cost you get. Then let's see the time. Remember, our time is equal to the distance over velocity or over speed. So our t here is going to be the distance. Remember, these two towns, A and B, from A to B, there we are having 500 kilometers over the speed. Now this is the speed which the aircraft is moving at. I think we see it's greater than the one which is still here, because here there is action of the wind. That's why it's faster than the other one. When it's still here, means when there is not anything like acting on that. Okay, over 235.4918. And so my time there is going to be so 2.123 hours. They told us the nearest minute. So this will be 2 hours, then plus 0.123 times 60. And so our t is going to be 2 plus. Now you get times 60. Why? Because these are hours and converting them to the minutes they want. So here I'm getting 7.28 to the nearest minute. Means now this will be 2 hours plus 8 minutes. So it's the same thing you have to do here. Part C. You have the distance. This is our A, this is our B, the distance between these two. 5 kilometers, 100 kilometers apart. As simple as that. So that's how you handle that. I wish you would. So from here, also do the same.